Hydrophilic substances attack polar molecules in water and dissolve. They have a high affinity for water. Hydrophobic substances have molecules that do repel water. They do not dissolve in polar solvents. The main difference between hydrophilic and hydrophobic substances is the geometric pattern. Water forms on their surfaces. Water spreads across a large area in hydrophilias, but forms droplets in hydrophobes. Substances with a high affinity for water are known as hydrophilic. When water comes into contact with such substances, it tends to spread evenly across their surfaces as opposed to forming beads, which happens with hydrophobic substances. The term hydrophobic consequently refers to substances with a low affinity of water and thus tend to repel water molecules. At the molecular level, hydrophilic substances dissolve in water due to their changed polarized nature. Thus, the polar molecule in water acts as a solvent when it comes into contact with hydrophilic substances, as the polar molecules of the substance easily dissolve in water. This is due to a partial positive or negative charge called a polar in the molecule that blends with the hydrogen in water. Hydrophilic substances are characterized by the fact that they only dissolve in water and not in other solvents such as oils. Hydrophobic substances, on the other hand, do not have a polar charge and thus do not bind with the hydrogen in water. These molecules are said to be nonpolar and thus demonstrates preferences for other nonpolar solvents. Hydrophobic substances tend to form mescalis when in contact with water as they do not dissolve, which is why their name translates to fear of water in Greek. They tend to repel water molecules but attract other nonpolar solvents. Hydrophilic and hydrophobic substances are often defined by the geometric shapes the water forms on their surface. Their geometrical shapes, defined by the angle of water droplets on a surface referred to as a contact angle, can either be less than 90 degrees or more than 90 degrees. When it is less than 90 degrees, meaning water spreads over a large surface, it indicates that the material is hydrophilic. When the contact angle is larger than 90 degrees, the water collects itself into droplets, making the surface molecules hydrophobic.